2.4 notes, complex numbers. This is page 2. I'm going to start at top, talking about the equality of complex numbers, and it's going to make sense, but it's one of those things until you say it out loud. Sometimes it's a little bit of a struggle. So, two complex numbers written in standard form like we have them here, a plus bi, c plus di, are only equal to each other if the real parts are equal and the imaginary parts are equal. So for example 6a, we want to solve for a and b. So real part has to equal real part, imaginary part has to equal imaginary part. For b, this one gets a little more involved. I've got real part 3a equals 9, divide both sides by 3, and a equals 3. Sorry, weird things happening. A equals 3. We got b plus 3 has to equal 8. Imaginary part has to equal imaginary part. So b equals 5. When we add or subtract complex numbers, it's going to be like adding or subtracting polynomials. We can only add like terms, so we've got to add real to real and imaginary to imaginary, or subtract real to real and imaginary to imaginary. So I am going to go ahead and rewrite this. Again, I'm going to do a little more work here than you probably are, without parentheses. And then I'm just going to list the real parts first, the imaginary parts second, and then I am going to combine like terms. 8 plus 3 is 11. 6i plus 2i is 8i. When I subtract, I have to make sure that as I write these without parentheses, I distribute that minus through those second set of parentheses. I get 4 minus 6. Plus 5i minus a negative 3i makes that plus 3i. 4 minus 6 is negative 2. 5 plus 3i is 8i. Again, we end up with a real part and an imaginary part. We are going to multiply and divide here. A is pretty straightforward. I cannot multiply these under the radical first, though. I don't want to make the mistake that I multiply by a negative by a negative and end up with a positive under the radical sign and then just take the square root. I definitely want to pull the square root of negative 1 out first. 4 times 5 gives me 20. I times I gives me I squared. And like we said on page 1, I squared equals negative 1. I get negative 20 here. B, we want to multiply these two binomials. We are going to go ahead and multiply just like we would a polynomial with a variable. So we're going to use the FOIL method to start. I've got 1 times 1, which is 1, plus 1 times 3i, which is 3i. 2i times 1 gives me a 2i. And 2i times 3i gives me a 6i squared. I am going to combine these like terms. I get 1 plus 5i. And I'm going to rewrite that I squared as negative 1. So I've got 1 plus 5i minus 6. 1 minus 6 is negative 5 plus 5i. As much as we don't like that negative hanging out front, we do definitely want to write this with the real part first and the imaginary part second. C is in here like this because it's real easy to forget that this means I am multiplying a set of binomials, even if they are exactly the same, and I cannot just square the first term and square the last term. So I've got 3 times 3, which is 9. 3 times negative 7i gives me a minus 21i. Negative 7i3 gives me a minus 21i. Negative 7i times negative 7i plus 49. Weird. I squared I get 9 minus 42i minus the 49, because we're going to multiply that 49. We're going to replace the I squared with a -1. I get negative 40 minus 42i. Again, we've got a real part and an imaginary part.